Oh, yeah. So yeah, we are installing all these areas and showing people how important the soil ecosystem and the structure of the soil is to having a healthy environment. Uh, and so I am coming in here. Alexis asked me to join in this and kind of talk about Alere and what we have happening with that. I have a little presentation that I adapted from one of Alexis's presentations that I could show you about the Alere system. But we are working on bringing in some really innovative biochar production facilities, utilizing a number of new technologies to make those systems more productive, as well as to make them more interactive with the ecological system. A lot of biochar facilities that create biochar focus on poor surface area, and in doing so kind of eliminate a lot of the environmental benefits by having different size pores in that biochar. So can I share my screen here? Let's see. So is it sharing?
Yep, you're good.
Yes.
And so this is our little presentation about Alere. And Alere is this really cool method of creating biochar in a flameless system that's a continuous flow through system that decreases its need to shut down and start up and so forth. Is just looking at some climate pathways as we change the way we're doing things in the world to be able to continue to have a world centuries in the future. And talks about a little bit about the activities of the Alere biochar system here, where we can capture and store carbon in the soil long term. For some of these biochar and historical biochar sites have had soils carbon stored in biochar in the soil for up to 10,000 years. So this is not like a compost edition where it's going to be stored in the soil for a few years before it's turned a couple times and then released back to the atmosphere. This is going to be in the soil long term and be able to make real change in nutrient cycling and biodiversity in the soil. It has the ability to suck up and hold those nutrients in place, working with that ecosystem to be able to deliver it to plants and hold those nutrients in that soil ecosystem to be able to continue it long term. And really actively restores biodiversity through different pore sizes in this biochar and how different types of microbes can live within it. It helps to decrease runoff. It holds water into the soil, restores that nutrient cycling that I've talked about a whole bunch already. And in doing so, increases the yields from these lands. In creating this biochar, we are able to use a lot of organic waste that would normally be going to landfills or just rotting in a pile somewhere, both in the creation of the biochar itself, as well as manure additions to charge this biochar to turn it into fertilizer, and has the ability to output electricity as well as heat for sterilization of other processes. So I apologize. I didn't really know I was jumping in here until yesterday, so I'm kind of running on the fly here. We have this pulls carbon out of the air and out of our waste materials in many different ways. It stores it in that in the soil through the biochar addition, but also in some of the enhanced weathering, where we would add some clay and silicate amendments to it, which actually allows it to continue to sequester carbon from the atmosphere, as well as decrease any nitrous oxide from the natural breakdown of organic matter in the soils, and lock that all kind of up in the soils. It also offsets using chemical fertilizer, which is a huge carbon footprint and is generally produced in areas such as you know, like right now, the carbon fertilizer prices rocketing because of the issues between Russia and Ukraine, and decreases the need for transportation, because these are modular systems that can be deployed in areas where there's high amounts of waste and need for these fertilizers. And also the dryer associated with these machines is able to dry this organic matter for less than 5% of the energy costs of traditional dryers for biochar systems. For every ton of biochar fertilizer Alere produces, it sequesters 10 tons of emissions, both in the long-term sequestration of carbon in the soil and in offsetting the need for chemical fertilizers. So that means that 300 kilograms of carbon is actually long-term stored in the soil for every ton of fertilizer used. And we are actually working on using a mycological component. So we're taking different types of fungi and inoculating rolls, the centers of these rolls, wrapping biochar. The biochar is then growing into the mycelium is then growing into the biochar, which we deployed in runoff zones or in streams that are impacted by agricultural waste. And then the biochar would be able to suck in those nutrients, and then the mushrooms would come in and pick the nutrients out of the biochar and allow that biochar to continue to uptake nutrients. As the mycelium grows through this roll and locks it up in the biological matter. At the end of its lifetime, we could take that and apply it to fields where we had a very biodiverse, biologically active fertilizer that already has this mycelium in it that will make associations with the crops that you fertilize with this, and be able to hold water in the soil, deliver water to plants during drought, and then also be able to pick nutrients and spread them evenly throughout the fields to make sure all these plants get the nutrients and the water that they need, even under drought conditions. Here's a layout of our myco capture packs, or MCPs as we're calling them, where we have a core of mycelium that's held within natural fiber netting, with the biochar on the outside also wrapped up in natural fiber netting, so that you don't have to remove anything when you go to put them in the fields. You can just grind them up and till them right into the fields there. And so in doing this, we're cleaning runoff, stopping the ecological impact that some traditional agricultural practices have on our environment around us. We can utilize waste to turn them into these. And then once they're done, they become fertilizers that enhance biodiversity and nutrient cycling, even having the ability to restore some degraded, non-productive agricultural lands. And here's just some links. This presentation here is all these links are active, and just articles about how people are buying up land as an investment for something coming in to be able to restore them. And so restoring our ecosystems through these products have the ability to enhance our economy, restore biodiversity, which is a leading cause of the climate change, restore food security, the health of individuals in these areas, adapt to a changing climate, while sequestering carbon and helping to stop it from changing so rapidly, while saving us water and ultimately increasing our security. And so these fertilizers, beating a dead horse here, pulling up water into the fields, decreasing runoff of nutrients, and really helping out in a variety of ways here. So the biochar that we're putting out, as I was speaking of earlier, has a higher biomass yield, which is higher carbon sequestration. We're actually creating this biochar at a lower temperature, which decreases our surface area on the biochar, but increases the number of different size pores. Whereas when you cook it at that higher temperature, you're creating all nanopores, where we are creating macropores, mesopores, and nanopores, where it will support bugs, it will support bacteria, it will support fungi, and it will support a wide variety of all of those things to create this biodiverse foundation for the ecosystem it's put into. I'm sure everybody is aware of the prices of fertilizer currently. This will not be tied to oil prices and gas prices. This is utilizing waste to restore these, to create these fertilizers, and as such, the price of it is much lower. And so this is our system here. The green is material flow, the red is energy flow here. And so we're utilizing some technology out of Sweden that actually reflects the heat at the ideal wavelength to evaporate water. And one of the big costs of biochar is actually drying the material that goes into the biochar creation. So we are eliminating a large cost of the production of this biochar by reducing that energy cost, as well as having the heat exchangers that will actually recycle all of the heat throughout this system. And once it's fired up, it actually uses less heat to operate, uses less energy to operate than it creates, which allows us to utilize heat for other processes and create electricity that we could feed to, you know, any paired process for this machine here. And here's a kind of a comparison of mineral fertilizers versus manure versus this type of fertilizer, and looking at energy, transportation, effect on climate, prices, geopolitical risk, as in who you're dealing with and how they're interacting politically, how much of the runoff from this fertilizer is being put into the environment, which is a huge issue, as well as the effects on the soil. And these have the ability to be tailor-made to specific fertilizer needs for fields as well. So, I mean, there's a whole lot of really cool opportunities to get these systems up and running. We are currently getting some investiture in Detroit here and throughout Michigan, where we're going to be landing these machines and actually looking to produce them in the United States here and get them to where they can be best utilized. Because they are containerized, I think this is the end of this is the end of our presentation here. Oh, the big thing about this is we're not using new technology here. We're just kind of really putting some pretty well-known technologies together in a way that augments all of these technologies. It's long known how mushrooms underlay our entire environment and choose for the ecosystem that exists on it. And we're just kind of adding this mycological component to kind of underpin the entire project and allow for it to spread like mycelium and interact in these ecosystems. So but yes, so we're really excited. We're really excited about the opportunities that this presents, not only for agricultural soil restoration, but also industrial soil restoration. Because a lot of these mycelial components have the ability to degrade a lot of contamination from hydrocarbons, from chlorinated and fluorinated compounds, and some even will bioaccumulate and remove heavy metals from soil. So being able to tailor the mycological components in these things really gives it a wide variety of usage to restore soil, whether it be urban soils or agricultural soils.
All right. Thanks, John. I would love to hear you talk for another hour or two or three or so. But we just kind of do these as a little teaser for what's out there. And so I'm sure that there are a few questions that people might want to ask at this stage. And thanks again, John, for for coming and joining us and giving us this presentation.
All right, thank you.
So anybody want to raise their hand to ask questions?
I'm on the phone, so I can't raise my hand, but this is Steve. Yeah, John, that was absolutely an amazing presentation. And pairing biochar with the mycelium, that's, really sounds like a great deal. So I'll just try to be as brief as I can. I just want your feedback on if you know anything on what I'm thinking here. So I'm on semi-arid rangeland and trying to figure out economical ways to restore the biology and the underground microorganisms. And it's very hard to do economically anything on semi-arid range, but one possibility of doing that is using the cow to spread that. And so there's a lot of different ideas on the ways we can use a cow to, give her the microorganisms, but also there's quite a bit of research on biochar to animals, and biochar is very, it increases the production and health, but also when that biochar passes through, that's a way we can get it out on the range. But it's because it's a kind of a far out idea that it's hard to get a lot of research or support for it. And then of course, all these things, as far as what's approved by the FDA is kind of a big question mark. So anyway, have you any experience with any of those kind of deals of feeding biochar to animals?
So that's one of the things that Alere in Norway has been working on, was a way to augment feed with biochar, and they would inoculate it with a number of different types of bacteria. And they showed that it was able to reduce the methane output of the cattle it was fed to by 60% as well, while increasing the carbon sequestration in the soil, as this biochar, naturally breaks down through the manure into the ground. We have not worked with starting to inoculate fungi into that feed yet, but that's something that we're looking to explore here in the near future.
Thank you.
Another one? Sue, go ahead.
What is the cost of a unit to produce this biochar? What would be the cost of the machinery necessary? I assume these are kind of portable units.
Yes, there's two sizes of units, and the unit itself. So we're currently having to produce them in China and bring them over here, and we're looking to utilize the capacity of the industrial capacity in Detroit to be able to start to manufacture them here. Currently, I do believe just the base unit, not including support for it, is around $800,000. But we're really looking to kind of move into where people who are purchasing these units have the ability to stamp them and operate them properly. So I know that Uwe and Alexis have more information on what they're looking for people who are buying into these units.
All right. And what size is that then, John? What capacity does that have, that 800,000 units?
So that was the large one. Let me had it in this PowerPoint here. Let me switch through it real quick and see. So it can put out, so I do believe 44,000 metric tons a year was the capacity of that. And these come in modularized containers that actually fold up and create their own roof. In some of our northern areas, it would have to be inside of a structure, but it it can load onto a truck and fold up like a container and be deployed onto a new site. And so it has some really cool capacity for like invasive species management, to be able to go out there, deploy one of these sites, create a whole bunch of biochar, and then be able to utilize it to restore the soil that these species have been removed from. There's just some really cool modular uses for these things as you can move them to different locations and easily set them up.
Great. And more questions?
I have a question, and I just kind of wanted to highlight, it sounds like, based on my limited knowledge, that you're working with a group in Detroit on getting this unit there. And so if you wouldn't mind telling us just a little bit about that group, or about what it's been like to work on soil health in like a community setting.
All right. Well, so I operate a nonprofit called Weyhrauch Pontiac. And so we're working with, we started a company called Dirt Labs. And Dirt Labs was originally working on microremediation through the Hatchery, which is a like green incubator accelerator international group. And we were actually introduced to Alere, and the investors in Dirt Labs are actually becoming the primary investors in Alere US. So we're working through Weyhrauch Pontiac, as well as we're opening up a chapter in Flint currently, to be able to not only create these biochars from waste in the area, but also be able to deploy some of these technologies in urban populations where you can really make a heavy impact and educate a lot of people on the importance of soil health. And so in those locations, in those communities, I find it's very important to give people hands-on understanding instead of trying to, I tell people that I don't teach anybody anything. I just show people cool things. If they like that, I'll show them something else. And if they like that, I'll show them how those two things are connected. And then they can start to develop their own interest and passion in these subjects. And then once someone's passionate about these subjects, it's super easy to teach how all these different connections come in.
Great. Thanks, John. One more question?